When making this shortwave radio, there are a lot of videos about it on my YouTube channel. I wanted to make here the front end, and I wanted to make it with a field effect transistor. And I always had more or less, yes, say always, success with the field effect transistor in the grounded source mode. But it did not want to succeed, and in this radio it always succeeded in the past, that circuit with the grounded source. But my idea was, let me study the field effect transistor somewhat better. And I have to be very precise, because when we are talking about field effect transistors, it's a kind of sea to drink. I'm only talking about small signal N FET transistors, like the BF245. It's from China. I bought them in China. And I also bought in China the BF256A, but at the moment that's not under test, only the BF245. So I want to say, hold this video very precise. I don't pretend that this will work with all kinds of other field effect transistors. There are so-called depletion FETs, enhancement FETs, and there's a lot of theory about field effect transistors in 1960s documents, radio magazines, etc., etc. But anyway, I tested this now out and found real amplification. With the other grounded source circuit, I only found, say, an amplification of 0. So in fact no amplification, and even weakening when I compare the signal at the output to the signal at the input. But now it's amplifying. Here is the amplification connected now to the sine wave generator here, and say the whole idea of this video is that you can set here, you can experiment with the values of this potentiometer here to the drain and the potentiometer to the source. And when you go to the World Wide Web and study, for instance, FET, field effect transistor pre-amplifier, you can see all kinds of circuits, and especially there's an enormous difference regarding this resistor here and this one. So sometimes this is high and the other one is low, etc., etc. Well, sometimes there's no capacitor here. In general, this looks a little bit like a grounded emitter circuit with a BGT transistor, but it surely is not such a circuit, because we take out the circuit from the drain here. There are two possibilities to take the signal out of the drain and of the source, and when I take it from the source it's weakened, but when I take it from the drain there's real amplification. So let me demo that. I think the video will be too long, but anyway, now it is connected here, the scope is connected to the output. We have this waveform, and now I connect the scope to the input. So here is the crocodile clip connected to the input, and this is the input signal. It is 2 volts. Now I connect it to the output. Sorry for all the movements. And now it is 2, 4, etc, etc. So a lot of amplification. So I want to use this also in the radio circuit that I'm working on, the shortwave radio. I always used in the past the grounded source circuit, but now I will try to use for the high frequency amplification, say the front end, this setup. I'm not sure if that will work, but anyway. And in that case, of course, I will change the capacitor here. It will be in the order of 100 picofarad or 50 picofarad. Output cap will be in the order of 100 picofarad or 50 picofarad. This will not be there. And say the idea is, of course, perhaps I forgotten to tell that you set here the potentiometers till you have a proper amplification of the sine wave, and then you can take the potentiometers out, measure their resistances, and replace them with a fixed value resistor. So let's turn a little bit to both the potentiometers. So now the upper one, that's here, this one, let's see what happens on the scope. So amplification goes down. So you can set the amplification here with the upper pot meter, and of course when the amplification is too high you will see distortion. Anyway, now I turn this pot meter here, 10K in the source lead. It's here. Here, now I turn this. Let's see what happens. We see also a lower amplification, but when we turn it to the maximum we see a lot of distortion. It means, in general, that the amplification gets too high. We get clipping here. So that's the whole idea of this video. Do your own experiments. It's very easy. Could be that when you copy a circuit from the World Wide Web it doesn't work, but this is, say, an experimental circuit that you always can get working. Of course it takes more time, and you have to make, say, this test circuit first. Anyway, look again to the waveforms. So let's go to a higher frequency. Still good amplification. Also more high frequency. Now we have distortion, so it means that this amplifier amplifies better on the higher frequencies, and I'm talking about 15 kilocycles or so. But of course, when we turn the pot meter a little bit, we can, say, diminish the distortion. Well, that doesn't succeed at the moment here, and the reason is that the input impedance is extremely high, and you need here a potentiometer to limit the input level to the field effect transistor. Anyway, thanks for watching. So, in my opinion, an interesting circuit to do experiments with.